That was very, very mean, Di.
Sorry, Mary.
Kia ora all, I'm Mary Crow. I work Ministry of Health, Emerging Health Technology and Innovation team based in Wellington.
Okay, Lance, you pick one more. Thanks, Mary.
I'm going to pick someone I don't know. Hamish.
Sorry?
Is it Hamish? Yep, there we are.
Yep, kia ora tātou. I'm Hamish Crockett. I'm the senior lecturer in health at Te Whatakiwara School of Health, University of Waikato, and I have research and teaching in digital health technologies.
Nice to meet you, Hamish.
Yeah, nice to meet you too.
Okay. Shall we start?
Yeah, we'll start. The numbers are pretty static at the moment, so yeah, we'll make a start. Get on to the good bits. So good morning, everybody. Welcome to this third workshop. It is the Australian New Zealand BioBridge. Very interesting topic today with some eminent speakers. As I said in a post recently, I think COVID might be wearing a bit thin in some people in terms of topics and presentation, but I think what we've got today is a little bit different. And like some people say about business, often a crisis brings out the best in people and accelerates quite a few good things. So COVID's definitely done that, and that's what today's session is about. For people who aren't aware of the Australian New Zealand BioBridge, it's an agreement between the Consortium for Medical Device Technologies in New Zealand and Liverpool Innovation Precinct. Across that agreement, there are 13 organisations, all but one are health and research institutes. And the purpose of the BioBridge was really to collaborate and work together to advance all aspects that we could of medical technology, and in particular, raise a profile of the contribution that medical technology makes to each country's economy as well. For Di, there in New Zealand, my colleague, our big goal is to try and curate and make collaborative research and make connections that mightn't ordinarily have occurred. And we've had great success with that to date. And in fact, next month, a number of researchers from the Liverpool side will be travelling to New Zealand to attend Health Tech Week and meet with some of the New Zealand researchers they've been working with for the past maybe year, which is exactly the sort of thing we want to be able to achieve. And as one of the objectives even out of this session is if there are people who have interest in some of the subject topics that our presenters are speaking about today, we're happy to connect you and expand each person's network. Anything else on that, Di?
No, I think kia ora kato, ko Diana Siu toko ingoa. So hi everyone, my name is Diana Siu. No, Lance, I think you covered everything really well, and really the purpose of these workshops are small, curated, and trying to connect the people who are interested in the topic so that we can collaborate across Australia and New Zealand. So yes, shall we can make a start, I'm sure.
Yep, we'll move into our first speaker, Professor David Lin. So David's bio actually looked like it was going to end up being a few volumes, so I've cut it down a little bit, David. He is an EMBL, European Molecular Biology Laboratory, Australia Group Leader and Program Director in the South Australian Health and Medical Research Institute Precision Medicine theme. He's also Scientific Director of the South Australian Genomics Centre and Professor at Flinders University. David and his research team investigate how microbes modulate the immune system in a range of contexts from infection, including COVID-19, to infant immunisation and cancer immunotherapy. He also leads a number of clinical studies, including NHMRC-funded systems vaccinology study to investigate the link between the microbiota and vaccine responses in infants, the COVID-19 immune responses study, and he's also the primary investigator in South Australia for the Gates Foundation funded BRACE trial, investigating whether the BCG vaccine, more commonly associated with TB protection, whether it provides protection against COVID-19. And today he's going to present his team's recent work showing that long-term dysregulation of the immune system occurs in convalescent individuals recovering from COVID-19. And we'll discuss how this dysregulation, it may be linked to symptoms of long COVID. I think I've almost given it all, David. So I'll hand over to you now.
Thanks, Lance. I'll just share my screen. Can you see my presentation there okay?
Ken, yep.
Great, I'll get started. Thanks so much for the invitation to speak today. As Lance, sorry, I'm just going to see if I can move this thing. No. As Lance has mentioned, I'm talking to you today from Adelaide in South Australia, and my research group is based here at this funky looking building called the South Australian Health and Medical Research Institute, which is located in the Adelaide CBD on the Adelaide Biomed City precinct, a major investment in biomedicine in Adelaide over the last 5 to 10 years. We're right beside the 800 bed Royal Adelaide Hospital, as well as other health and medical research institutes from some of the universities in Adelaide. My group is a systems immunology group, and we use a combination of tools, including computational, multi-omics, and more classical immunology approaches to investigate how microorganisms, both pathogenic and commensal, modulate the immune system in a range of different contexts. The group spans from in silico bioinformatics, tool development work to in vitro and vivo, and Lance introduced some of the clinical studies that we also lead, and I'm going to talk about one of those studies today, a long COVID cohort study that we set up pretty early in the pandemic. So long COVID doesn't need a whole lot of introduction. I think there's been a huge amount of interest in long COVID, both scientifically and in the popular media, just highlighting some of the popular media articles here. So there's huge interest in understanding what it is, what's our risk of getting it, and is there anything we can do to treat it if and when we do get it. The syndrome has also been referred to as long haul COVID, post-acute COVID-19 syndrome, PASC, or as preferred by the World Health Organization, post-COVID-19 condition. Post-COVID-19 condition or long COVID occurs in individuals with a history of probable or confirmed SARS-CoV-2 infection, usually 3 months from onset of COVID-19 or within 3 months of onset, with symptoms that last for at least 2 months and cannot be explained by another diagnosis. The symptoms may be new onset following initial recovery. So you can think you're fine and then these symptoms can emerge, or they can persist from the initial acute illness. And there's also been reports of symptoms fluctuating and relapsing over time. Common symptoms include fatigue, shortness of breath, cognitive dysfunction, but more than 50 different symptoms have been reportedly associated with long COVID. Whether all of those really are or not remains to be determined. The incidence rate of long COVID also varies pretty dramatically in different publications, with suggestions of 5 to all the way up to 80% of COVID-19 patients being impacted with one or more symptoms. That highly variable incidence rate likely reflects other factors such as vaccination, the variant of SARS-CoV-2 that individuals are infected with, which likely have different associations with likelihood of developing long COVID. Little is known about the molecular or immunological underpinnings of the disease, but multiple large cohorts are now being assembled around the world to study it. And in fact, given the reports, it's been relatively slow going to get large, well-powered studies up and running to investigate what's going on here, given the potential burden of disease involved. One of those studies that I thought was most interesting, published recently in Nature Medicine, was a study of cardiovascular outcomes in a cohort from the US Department of Veteran Affairs. More than 150,000 individuals in that cohort with COVID-19 investigated epidemiologically in comparison to 2 control cohorts. And what they found was, beyond the first 30 days after infections, individuals who had previously had COVID-19 were at significantly increased risk. You can see some of the odds ratios here of a whole range of cardiovascular diseases, including stroke, myocarditis, and many others. And these risks and burdens were evident even among individuals who were not hospitalized during the acute phase of infection. So in those individuals with what might be considered mild or moderate disease, there seems to be significant risk of a cardiovascular event post-COVID, regardless of the disease severity. The good news is that vaccination appears to significantly reduce the risk of long COVID. There's been several studies suggesting this. Now, this study here from Israel showing if you've been vaccinated with 2 doses, you essentially have the same risk of these symptoms as uninfected individuals. So obviously getting vaccinated, best possible protection you can have against not only active COVID disease, but long COVID as well. And the UK Health Security Agency also did a recent meta-analysis of multiple different studies and found that 6 of the 8 studies suggested that vaccinated cases were significantly less likely to develop symptoms of long COVID. So a little bit of good news there if you have been vaccinated. So the cohort that we established was a collaboration between my group at SAMRI, the University of Adelaide, Flinders University, the Women's Children's Hospital here in Adelaide, and the Royal Adelaide Hospital. Relatively small cohort, 56 patients with mild moderate disease, 13 with severe critical disease, and 13 uninfected healthy controls. It was a relatively small cohort because we were fortunate in South Australia to have little or no community transmission of the disease until borders were reopened towards the end of last year. So what we did was, after these individuals recovered from active infection, we brought them back into the clinic and collected blood samples from them at 12, 16, and 24 weeks post-infection. We've actually gone on to continue to monitor those individuals at 1 year and 18 months, and are now following those individuals out to 3 years post-infection. We measured a number of different parameters in those individuals, including their antibody responses against the virus. We did deep immunophenotyping of peripheral blood mononuclear cells, enumerating about 130 different immune cell populations. And we also did total RNA sequencing on blood samples, with sequencing more than 50 million reads per sample per time point. To mention, the individuals were all infected with the original Wuhan variant in 2020. And as I've said, there was no community transmission in SA during the study period. Not the case anymore. So the risk of re-exposure in the study is negligible. The individuals were not vaccinated because vaccines had not been rolled out at that stage. You can see that our mild moderate cohort is well age matched to our healthy controls, but as has been reported, those with severe critical disease tend to be older, and they tend to be male as well. The first thing we measured was antibody titers against the spike and RBD. portions of the spike protein. And what we found was that antibody titers were persistent to 24 weeks post-infection. So stable antibody titers indicative of likely good subsequent immunity following infection. Those titers were significantly higher in those individuals with severe disease originally. So I guess that's a small consolation prize for getting through severe disease, is that you may have stronger immunity going forward. As I mentioned, we've also enumerated 130 different immune cell subpopulations in these individuals, collected at 12, 16, and 24 weeks, and from healthy controls. What you can see in this heat map here, red means more of a particular immune cell population, stars mean the level of statistical significance, and what you can see in just some of those 130 immune cell populations is significantly increased numbers of a whole range of different immune cell populations, but particularly innate immune populations associated with inflammation, including neutrophils, monocytes, and NK cells in those individuals recovering from COVID-19 infection at 12 weeks post-infection. You can see that there isn't a clear separation between individuals that had previous severe disease versus those that had mild moderate. So this seems to happen in the majority of individuals. You can see that this phenomenon starts to resolve over time. So less red and less stars here at 16 weeks post-infection, and even less again at 24 weeks post-infection. Although there are some changes in immune cell populations that persist out to 6 months post-infection. We also did see significant increases in a range of B and T cell subsets, which we expect, and that likely contributed to adaptive immunity against subsequent infection, at least with the same strain. As mentioned, we performed RNA sequencing on whole blood collected from these individuals, and what you can clearly see in these MDS plots is blue are the healthy controls, and at each time point the blue is separated from the convalescence, indicating that there are significant changes to the transcriptome in those individuals at all 3 time points. In terms of the number of differentially expressed genes, nearly 1,000 differentially expressed genes in convalescence at 12 weeks post-infection. Again, you can see this kind of resolving over time at 16 and 24 weeks. But even 6 months later, there's still about 250 genes that are significantly different on average between convalescent individuals and aged matched healthy controls. So what is different about them? Well, most of the genes that were upregulated in convalescence were known biomarkers of inflammation and innate immunity. 2 examples here, the S100A8 and HMGB1. What you can see is significant increases in the expression of these inflammatory markers in the blood, regardless of whether you have mild, moderate, or severe critical disease. And again, a tendency for these biomarkers to start to resolve over time, but even at 24 weeks post-infection, these biomarkers are significantly elevated in convalescence compared to healthy controls. Another way that we can look at this complex data is what we call a blood and transcriptional module analysis. To do this, we use a technique, a computational biology technique called gene set variation analysis, which reduces variation captured in more than 20,000 genes that we profiled to an activity score for 256 predefined blood transcriptional modules in each individual. We found that 80 of these modules were differentially active in convalescence compared to healthy controls. If you just look at some of these modules, each dot here represents the more red the dot is, the more active the module is compared to healthy controls. You can see at 12 weeks post-infection, nearly everyone has these changes. Some people start to resolve them around 16 weeks post-infection, much more people start to resolve them around 24 weeks post-infection. But there are this group of individuals that have this persistent transcriptional changes. And we were interested to know whether those were the individuals suffering from long COVID or not. So the question we next posed was, is this immune dysregulation more evident in those convalescents suffering from long COVID? To investigate that, we had about 30% of the individuals in our cohort were referred by clinicians to a long COVID clinic, and more than 50% of the individuals reported at least one long COVID associated symptom. There's a strong agreement between those that were referred and self-reported symptoms, as you might imagine. Interestingly, referral to the clinic was not significantly associated with disease severity. So even if you only had mild, moderate disease, there was still a reasonable chance that you would end up with these long COVID symptoms. So we reanalyzed our transcriptional data, comparing gene expression responses in those convalescents that were referred to a long COVID clinic compared to those that were not referred to a long COVID clinic. So we're not comparing to healthy controls anymore, but comparing within convalescents. And we found 446 genes that were differentially expressed at 24 weeks post-infection in convalescents that were referred to the long COVID clinic. We did not identify differentially expressed genes at 12 or 16 weeks post-infection, although as I've shown you, all convalescents had substantial changes in gene expression compared to healthy controls at these time points. And we interpret these data as being that changes to the blood transcriptome persist in individuals referred to a long COVID clinic, whereas they tend to resolve in convalescents not suffering from long COVID symptoms. We did not find any differences in antibody titers or immune cell populations that were associated with referral to the long COVID clinic. So a pathway analysis of these changes in gene expression in those referred to a long COVID interestingly revealed a number of pathways related to platelet activation and platelet numbers to be downregulated in those individuals referred to a long COVID clinic. Further analysis of that data using cell type enrichment analysis again identified a whole range of cell types related to platelets and megakaryocytes that were predicted to be significantly downregulated in individuals referred to a long COVID clinic. And if we just plot the expression of a very well-known platelet factor PF4, we can see that the expression of that platelet factor is significantly reduced in individuals referred to a long COVID clinic. So unfortunately, we don't, because we were working with PBMCs, we don't have platelet counts on these individuals, but the transcriptional data suggests mild but persistent thrombocytopenia, so low platelet numbers in long COVID patients, but obviously that needs to be confirmed in future studies. There are a growing number of case reports of thrombocytopenia in COVID-19 patients, and interestingly, fatigue is one of the most commonly reported side effects of long COVID, and is also a common symptom of thrombocytopenia. So that's intriguing data that we have from this analysis. Finally, we also identified that this biomarker associated with neurological damage, S100B, was significantly increased in individuals referred to the long COVID clinic, which may correlate well with the fact that many of the patients referred to the long COVID clinic reported neurological symptoms. Finally, because we had all this type of data measured on the same individuals at the same time points, we were able to build these correlation network analysis of the relationships between gene expression modules, immune cell populations, and antibody titers. And as you can see, there's some very strong correlations between many of these features that we've measured. So changes in certain immune cell populations, correlated with some of the transcriptional changes that we observe, and some of the factors that we identify correlate with the antibody titers against the virus that are ultimately raised. So I'll start to conclude there, nearly at the end of my time. So most studies investigating immune dysregulation following COVID-19 have assessed these responses at 2 to 12 weeks post-infection. Here we report an integrated analysis of immune responses in individuals recovering from COVID-19 at 12, 16, and 24 weeks post-infection in comparison to healthy controls. As I've shown you, there's long-lasting antibody responses, particularly IgG responses, to at least 6 months post-infection. In fact, we'll have a paper coming out soon showing that these antibody responses persist to at least 12 months post-infection. Those antibody titers are correlated with disease severity. Our cohort in South Australia is particularly well suited to assessing the durability of antibody responses due to negligible risks of re-exposure, reinfection in South Australia during the period of this study. I've also shown you that we profiled immune cell populations in these individuals and found notable differences in many innate immune cell populations that were significantly increased in convalescence, particularly at 12 weeks post-infection, but many of these changes persisted until at least 16 or 24 weeks as well. And finally, I've showed you that the blood transcriptome of convalescence was significantly perturbed compared to healthy controls, largest number of differentially expressed genes at 12 weeks, but this dysregulation persists to at least 6 months post-infection. And these data suggest an ongoing inflammatory response and immune dysregulation in COVID-19 convalescence weeks to months after infection. Further work is needed to understand whether this dysregulated immunity has implications for how these individuals will respond to other challenges such as infection, vaccination, or management of chronic diseases. While the majority of convalescents returned to baseline, those referred to long COVID clinic did not, and more than 400 genes were identified as being differentially expressed in those individuals. Interestingly, these differences were only evident at 24 weeks post-infection, suggesting that while transcriptional dysregulation resolves in many convalescents, it persists in those individuals suffering from long COVID symptoms. And I've suggested that the data could indicate a persistent mild thrombocytopenia in these patients, and further work is needed to assess whether this signature is causally associated with long COVID, and if so, whether strategies to treat thrombocytopenia might be effective at relieving long COVID symptoms. So I'll finish with acknowledging the people in my group, particularly Fergal and Miriam, our collaborators on this project, Branka Agribor, Simon Barry and their teams, all the clinicians at the Royal Adelaide Hospital, and the South Australian Genomics Centre for support in the genomics analysis, and the funders, the Flinders Foundation and Hospital Research Foundation. Thank you for your time.
Wow, thanks so much, David, for that. Certainly a good example of collaboration with a number of organisations. I'm happy to take a few questions now from people joining this session. We also have some time for questions in a panel format at the end. So anyone want to ask any questions of David now? Or just while you're thinking about it, I've got one. You mentioned the thrombocytopenia was mild, and I might have missed it. I don't know, is it to a degree that it may also be sufficient to cause any bleeding disorders as well?
Yeah, we're kind of a little bit restricted in being able to predict, you know, we're kind of guessing that it's mild, given that, you know, we're not seeing very strong signatures. You know, this is something that we're picking up in the transcriptional data. You know, it's not like there's a complete loss of platelets predicted or anything like that, but it does seem to be a bit mild if persistent. As I said, we don't unfortunately have platelet counts on these patients because we were working with PBMCs. So we're trying now to see if we can collect samples in additional individuals to actually look at what's happening with platelets a bit more closely.
Lance, if you don't mind, I'll ask a question of David and just also more of a comment. Look, in the clinical space and being kind of the Liverpool, southwest of Sydney, which was probably one of the worst affected places in Australia and probably New Zealand with COVID, we do have clinicians and clinics that are looking after these patients. So there are respiratory physicians and our rehab physicians. So, I mean, if you need any help progressing or getting some kind of retrospective data, we'd be happy to help. One of the respiratory physicians is looking at all our ICU patients and following them up in our clinic. So, there's certainly room for collaboration here to see, because, since it wasn't prospective, you'll have to work off whatever data or information is available, but happy to help with that and provide you with contacts and a list of patients. So
excellent. That'd be very helpful. Thank you.
Yeah. The other thing in terms of prospective stuff, Anders Anneman, who's the director for research at Liverpool ICU, is doing a prospective study on our COVID patients. It's called the VETIPAT study, and he's looking at point of care. It's a platelet function test.
Okay.
Who present with COVID to identify a subgroup of patients who would benefit from prophylactic anticoagulation, because as you know, and you've identified, the coagulation cascade in this instance is probably not, it's going to more likely cause thrombosis than it will cause bleeding. So he's got a prospective study called VETIPAT, and we are doing point of care platelet function testing on these patients, and he's got a whole protocol. So quite a lot of room to collaborate with him and with our group. So maybe we'll get in touch offline and I'll put you in touch with our group. So
that'll be really helpful. Thank you. And yes, as I said, we're continuing to follow this cohort as well in South Australia, but also recruiting new patients now that case numbers are less limiting in South Australia than they were previously.
Yeah. No, we had 450 patients in our cohort. So
excellent.
Quite a big database that we are maintaining, and we're doing a fair bit of, a lot of it is retrospective, unfortunately, but we're doing a lot of retrospective work on that group that we've got.
Excellent. Be delighted to chat more offline.
Yeah.
Right. Thanks for that, Deepak. Yeah, Di.
Yeah, I've got a really silly question probably. So would these findings be similar for people infected with the Omicron variant? Or would you find, would they be more severe in terms of the dysregulation? Or would you find different patterns?
Yeah, so the short answer is we don't know. There's been, because Omicron hasn't been around long enough, there hasn't been very many long COVID focused studies investigating that. As I said, we are continuing to recruit patients here in South Australia to see whether similar effects occur after Omicron infections or not. I guess I would predict, given that disease severity does seem to be milder in Omicron, that the effects on long COVID would be as well, but that's just speculation at this stage. I'm not aware of data that have investigated differential outcomes regarding long COVID, depending on the strain that you were infected with. Obviously, vaccination does seem to give good protection, so that one would expect a milder long COVID symptoms, given that the majority of the population are vaccinated here, but we are also trying to recruit unvaccinated individuals who subsequently got infected as well.
Okay, thanks. I mean, I guess one other thing would be, it'll be fascinating to understand why some people are exposed to COVID and they live with the people who have been, who've been COVIDed, but they still don't get, they don't get the illness at all.
Yeah,
would you be
so there's
looking
a
at
lot of
such a study in
interest
the future?
internationally in trying to understand, what are the triggers of this immune dysregulation that have now also been reported by others. There's a number of theories out there, but I don't think any one are proven at this stage.
Fair enough.
More of a comment. I'm really taken by the range of symptoms. I think you said something more than 50 symptoms reported. I think I saw 25% report hair loss. Not something I mean, 25% is huge. Like, I'm so glad I haven't got it yet, because I don't have a lot. That scope of symptoms is just remarkable.
Yeah, it is a large breadth of symptoms. I think one has to take those statistics carefully. There will be substantial reporting biases and other factors, and as long COVID has been popularized in the media, I think people are much more acutely attuned to symptoms, and it's interesting the rates of many of these symptoms in a healthy population are actually very high as well. So while it's alarming, it's probably not as alarming as it sounds in some of the statistics.
Okay, so I can't blame my hair loss on COVID. Thank you for that, look, and people, I'm sure people will think of some other questions as we go along. But I think we'll move on to the next presentation. Thanks so much for that, David.
No problem, thank you.
Yeah, and we'll definitely make that connection between yourself and Deepak and Anders later. Yeah, thank you. Deepak. Di.
Yeah. Mary. Oh, Mary. I think Mary's just giving us a clap. She wasn't raising her hand for a question.
Oh, okay.
It gives me great pleasure to introduce Professor Chris Pemberton as our next speaker. Chris is from University of Otago, but based in Canterbury, and he is really well known for his work in cardiac biomarkers. And it's a really nice segue to what David's just talking about in terms of antibody responses to COVID infection versus vaccination. How long does your vaccination last? Because I think in the States, if I'm not mistaken, my sister was telling me that they're on their way to the second or third booster, and similarly in parts of Asia. So yeah, Chris, thank you for being here and looking forward to your talk. Over to you.
Yep, thank you. I'll share my screen now. I believe I should share that one. And can everybody see my screen? Is that working?
Yep.
Hang on a minute. And you should be able to, that's better. You can see the slideshow now. That's better.
Yep, that's it. Great. Thanks.
Perfect. Okay, so thank you, Di. Yeah, I'm from the Christchurch Heart Institute. I spend half which is in Canterbury here in New Zealand. I spend half my life dealing with them, and I spend the other half of my life being the CSO of a spin-out company that we've created out of that. The information I'm going to present today has come out of some funding that we got from MB, which was purely, it was almost opportunist, but we really do appreciate the chance to talk to this excellent initiative of the Australian New Zealand BioBridge. So the Christchurch Heart Institute is in Christchurch, associated with the hospital here. This is an old photo, that's Christchurch Women's, and there's a new outpatients out of here. So this is quite an old photo, but the School of Medicine building still stands there. That's the main building. And this is what Christchurch looks like if you stand on top of Scarborough Hill. Looking that way, you've got the Southern Alps where everybody goes skiing and tries to break their knees. And behind you, if you jump off the cliff, you're in the Pacific Ocean, and it's a long way to Chile. So it's right on the coast there. Our group, as Diana indicated, is primarily known for work in cardiovascular arena, and we have a number of different cohorts of around about 35,000 samples that we've got in minus 80 freezers plastered around the location here of all sorts of different people with varying cardiac disorders, and we've contributed quite a lot to the guideline literature over the years in terms of what markers can provide for clinicians in the real world setting, what to do with them, how to measure them, when not to measure them, which is even more important in some respects. And so that's primarily an area of initiative. The work today came from the New Zealand Ministry of Business Innovation and Enterprise, or MBIE as it's known. And it resulted from, everybody got locked down in New Zealand in March and April 2020, along with the rest of the world. And I was sitting at my dinner table at home trying to do something useful. And I got a call from the Vice Chancellor of Research of the university and said, the government's introducing a COVID Accelerator Innovation Fund. You should have a look at it. And I had a look at it, and I spent about an hour going through the document, and I thought, yeah, this is something that would be interesting. So I sent off an EOI to MB, and 70 minutes later, I got a reply that said, yeah, this is interesting, you should submit a full application. So we did that, and then a month later, we got $990,000 out of the government for work for developing COVID antibodies and relating it to what we know about cardiovascular disease, because everybody was concerned about that at the time. And I would just like to recommend that as a method of grant funding in New Zealand. I think that's extremely efficient and very timely. And you know, it really was something that was needed at the time. But it's the most unusual grant success I've ever had, instead of having to wait for the obligatory 6 or 9 months. So what did we get the money for? We needed to make antibody assays because they weren't around at the time. So we said we can do that. And we also wanted to measure the spike protein, which nobody knew exactly what it was going to do. And this was clearly going to be useful going forward. If the spike protein was doing something deleterious or it was sticking around for a very long time, there needed to be a way to gauge in concert with symptoms, something about going on about that. We were going to apply all our usual clinical heart tests and some of the in-house novel ones that we've created to the cohort of patients that we were going to recruit, which was up to 3,000 people. And the key objective was that we were going to collaborate with anyone and everyone, particularly here in the Christchurch region, New Zealand, if they wanted to come on too. So our assay systems were based on the Luminex multiplex assay system, which is really a glorified flow cytometer that can put multiple different shaded beads through with different antibodies on it, so you can measure multiple different markers at once depending on the shades of laser resorption you're getting out of the flow cytometer. And we were primarily at that time interested in the antibodies directed towards the COVID molecule and what was going to come out of that, and see how they performed. So we've set up a study to look at people primarily across COVID vaccination, because as everybody here knows, until recently, New Zealand has been pretty naive to COVID until around about August through November last year, when we got the Delta wave, and then through the Omicron wave, which has hit everybody else now. So we had a unique opportunity there to see what the Pfizer vaccine, which was the vaccine that was being used in New Zealand at the time, still is, and what happened. And so we noticed that we isotyped it according to IgG, IgA, and IgM on our Luminex assays. And you can see here, this is to the total spike protein and then to the receptor binding domain on the right. And you'll see that pre-vaccination, 1 and 2 weeks after that, and then 4 months out after vaccination, that you get, there's quite a heterogeneity here in the pre-vaccination to the spike protein. And I've spoken with some of the immunologists here, and they're wondering whether there's been crossover from previous coronavirus infections of certain types, HK93 or HKU1 or whatever the numbers are, OC43 or whatever they are, the known coronaviruses, and whether there's been some crossover there to the whole spike protein of some of the antibodies that have been flowing around in the population. Pre-vaccination, they went up. This is a logarithmic scale. And we found that out to 4 months, we were getting a reasonable persistence with the to the whole spike protein. The same to the RBD. There was an elevation that persisted out to 4 months after vaccination. They did drop as a general rule, but they did remain from the 2-week to the 4-month, but they did remain elevated and certainly detectable. Same for the IgA to the S1. IgA to the RBD, you can see that there's more of an incremental rise here in the IgA, and I have to say that IgA has emerged as something of great interest to us in terms of the antibody response, and also for the cardiovascular sequelae, because there is some evidence there suggesting an IgA response is intimately linked to how your cardiovascular system is going to play out. So we were very interested to see that in vaccination alone. IgM, it's very hard to tell here. Speaking with clinical immunology colleagues here, some of the rules that they've observed about IgM persistence and then going away in the early stages of vaccination and infection, some of those rules appear to have been kind of broken with COVID. I don't know anything about that. I'm not an immunologist, but that's the feedback I'm hearing from them, that there was very minor rises in it, then it doesn't really seem to do anything. The data down here is the Roche Cobas EUA approved assays, and they do a fudge factor where they automatically assume everybody has nothing. And so if you give somebody a sample, you have nothing in the pre-vaccination, and you can see there a minor elevation and then a greater elevation after 2 weeks after your second vaccination, which drops away after about 4 months. To the nuclear capsid protein from the vaccination, nothing happened, and that's exactly what's supposed to happen, because the Pfizer vaccine only delivers the spike protein to your system. You should not have antibodies being produced to the nuclear capsid, and that's what we found. So that was all good. We benchmark our assays to the Roche system and also to the Euroimmune system, which are approved immunological detection systems. So we'd managed to create reasonably quickly there some antibody assays that were making sense, which was kind of new for us, but edifying at the same time. What we were also interested in is what happens to known cardiac and metabolic hormones across the time period of vaccination. And I'm pleased to report that not a lot, really. So known markers of cardiac dysfunction, particularly NT-proBNP, which is a measure of how well your heart is pumping, its actual contractile performance, that was unperturbed pre-vaccination and immediately post-vaccination after 2 weeks. The 4-month data is not in here, but I can tell you now that for all of these things, they're pretty much the same as the post 2 weeks, so nothing seems to happen across that time period. HSTNT, cardiac troponin T, which is a marker of myocardial damage, in fact necrosis, the tissue has died. What they found now with the new high sensitivity assays is that everybody has a certain amount floating around, and it doesn't appear to do anything there. These two are outliers. This person here, when they came in both times to the clinic, they were late for their vaccination and they ran in. And we don't know what's going on there, but getting vaccinated seemed to resolve it, which was interesting. GDF15, which is another pleiotropic marker which floats around and is intimately linked and a very good predictor of cardiovascular outcomes. And in early papers that came out in Cell and Nature, in looking at what COVID did, this is the original strain that came out when everybody was locking down at the beginning of 2020. GDF15 was one of the cellular proteins that was linked to major cell effects and proteins that were altered in signaling pathways. And what interested us was that we noted in almost half of the group, GDF15 saw a rise after the second jab, and that persisted for 2 weeks. And the average elevation was 23% in those people. One person had a 64% drop after the second jab, so whatever. But out of the 3 clinically approved markers in cardiovascular, the GDF15 was the one that gave the most variability. It doesn't mean anything. The levels were pretty normal, but it appeared to be the most responsive, however subtly, to the vaccinations. Other used markers such as fatty acid binding protein 5, which is a marker of adipocyte function, nothing happened there. TACI is an immune response, nothing happened there. IGF-BP3, which is a surrogate for bone metabolism, nothing happened in there. Fibrinogen and clotting, which was a big issue and a worry, nothing happened there. SUPAR and CRP, known markers of inflammation, they were all pretty stable. So it was reassuring to see that across this cohort of people who were naive to COVID but in being vaccinated, that across both vaccinations, and then for out to 2 weeks afterwards, nothing was happening within major cardiometabolic markers that are of interest to clinicians. We then asked the question, if we look at all this data, can we take your baseline values of some of these markers and see how well you're going to do out to 4 months afterwards? And the short answer is maybe. So we used the Roche approved assay, and we looked, if you combine the baseline levels of fibrinogen and suPAR, you have to normalize them first, which we did. There does seem to be this inverse relationship such that if you had a higher combined normalized value of these two markers, at 4 months, you tended to have a lower level of antibodies compared with those who started with a lower level. They persisted out out to the 4 month period post-vaccination. What that means, we don't know. It's an observation, but it does seem interesting in that a known marker involved intimately with the coagulation cascade, and suPAR, which is a known inflammatory marker in a number of different conditions, combined to give you this kind of response. So our assays, what we then wanted to know was, okay, can we tell who has had COVID from not having COVID? Because we began some, we're more advanced now, but at the time we were going into serosurveys in the public to find to see, what the true level of COVID infection in the general public was, because as everybody knows that the rate of PCR proven cases is not the complete picture. There's always other people in the background for whatever reason who have been infected but don't come to the attention of the official statistics. So we want to recruit 3,000 people. It's taken a long time for us to get ethics to do this finally, and we've just completed the last aspect of that and been able to report people back their antibody level results. It's been a bit of a rigmarole to get that through, but we finally got that. So out of the 320 recruits, we've had 1,400 people sign up in about 6 months, which is not bad. We've gone through the clinic with 320 of them and had them bled out and had all their information required. We've got another aliquot of pre-COVID controls, people who didn't have COVID, and then we took some pneumonia patients where we had biobanks because they could be an interfering factor in the assays. And then we've done 172 recruits here from the study into this figure here, which is called a ROC curve. And basically the green line here, to sum it up, is like flipping a coin. Your test is going to give you useful information or not. Movements away from this middle line tell you something. The ideal test would have an area under the curve of 1, which would be a straight line across to this top left-hand corner and down. That means you have the perfect test. You have reached diagnostic nirvana. You can collect the Nobel Prize and go home, because there is no test that has an area under the curve of 1. But anything that moves the line to the top left-hand corner or the bottom right-hand corner is indicating clinical utility. If we take the positive case of going to the top left-hand corner, anytime your area under the curve gets over 0.7, 0.75, you are reaching clinical utility. Clinicians become interested because it's providing useful information. The area under the curves of our assays versus the Roche assay, our IgG COVID assay is non-inferior to the Roche assays. IgA, interestingly, is good enough, and IgM, as we expected, didn't really perform as well as the other two types of antibodies. And just a reminder here that serology is only useful a couple of weeks after infection or vaccination, because you can't use it to diagnose acute disease. Based on these results, we're wondering if the Roche assay is more specific. Whether it's driven by the IgA response, whereas the receptor binding domain assay that they've got, is it driven by the IgG response? IgM is no good. And again, this data combines with our earlier vaccination data, and we really do wonder about IgA. It's a immunoglobulin of interest to us, which we are going to have a very good look at when we come to do the whole 3,000 people that we're recruiting as a variable for future prognostic outcomes and seeing how it relates to other markers. The excellent presentation before, I can't match that, but the data here does seem to be consistent with what was presented earlier. This is looking at how persistent are COVID antibodies after vaccination, 23 people, and then 30 people in the group who are post-COVID. All of these people post-COVID here are Delta. They're not Omicron, they're Deltas. These people were recruited prior to the Omicron wave hitting New Zealand. So here, this is the COBAS RBD and the nuclear capsid assay on the right here. These are people here 2 weeks post inoculation and 4 months post inoculation. You can see there's the 2-week elevation in RBD antibodies has dropped away, but it's still quite measurable. In the nuclear capsid case, there's nothing there, and that's exactly what we should see. So you can use the nuclear capsid assay as a surrogate to try and tease out, even if they're vaccinated, who might have had COVID or has been vaccinated with a different type of vaccine, such as the Sinopharm one. It's not being used in New Zealand, but you can use it for that. But we've used it here to, because we're only using the Pfizer vaccine, we've used it here to look at who may have had COVID. And every single person out to 24 months post-COVID, these people here are at 23 months, every single one still has measurable nuclear capsid antibodies. So when we report back to patients, we have to be very careful about that for 2 reasons. One, just because you've got circulating antibodies doesn't tell you anything about your immunity. And 2, please don't go and talk to your GP about this, because this is really going to annoy them. The GPs are busy enough as it is. They don't want somebody ringing them up, persisting them, because those turkeys at the CHI have gone and measured their nuclear capsid antibodies and they can't tell us what it means. So we have to be careful about that. But it is an interesting fact. There is still the persistence of these antibodies out to 2 years by the look of it. It's highly variable, but it's there. Now, these antibodies, how do they relate to the known cardiac markers that we have? And the upshot of it is that they don't really relate to anything at the moment, other than IgM, which has a negative relationship with all of the 3 cardiac main markers that we're interested in: NT-proBNP, HSTNT, and GDF15. The numbers there are not high, and we'll see what happens, but already a trend is apparent that IgM is the one that is most closely linked to the cardiac markers. What that means, we don't know, and we're going to have to try and work that out into the future. We're also doing unbiased mass spec analysis. So what we're doing is we're taking people who have been vaccinated and are COVID naive, and we're taking people we have some people who have not been vaccinated and have had COVID. And we're trying to work out if there's any differences in the mass spec unbiased profile of these people, protein identifications, to see if these 2 processes are giving different results in terms of you've got vaccination through getting a vaccine, and you've got vaccination in inverted commas through getting the whole COVID virus itself. The other thing we're doing is we're going to look at people who have had COVID, and then when they recover, who does well and who doesn't do well, to see and look at the proteome expression differentials between the 2, kind of like was talked about before, where there was the immune dysregulation and the clear separation of gene expression in the people with long COVID versus non-COVID. We've already had a couple of things that stick out. One of them is a thing called neurofilament heavy polypeptide. It's, for some reason, it's linked it all to the Radis novegicus things here, but they're 100% homologous in the human. I don't know why the protein system did that. Our technician's going to have to go away and look at that. But we've confirmed this in the human sequences as well. So there's a lot of different proteins in there that seem to be differentially expressed in the COVID vaccinated people compared with those who haven't been vaccinated and then had COVID. The next thing we're going to be doing is we're looking forward to, we want to make a machine, because we've got lots of things that we think we can stick in a machine and measure at point of care, which we think might be useful. So we can chuck a whole bunch of differential cardiac markers in there, along with the immunoglobulins, and then the things that fall out of the mass spec and the cardiac marker differential analysis between long COVID, non-COVID, and everything, and put this all in a sort of flow cell type thing. We want to be able to get that round, so you make it very simple. We want a readout to the user, and the user is going to be a different range of specialties. There'll be lab technicians, nurses, pharmacists, ED docs, even med students if they behave nicely. So you have to make the readout useful, such as green is good or red is bad or whatever, something like that. You want to have the turnaround fairly quickly. This is all a kind of standard technology, but it just needs to be refined, and there will be pitfalls. And we want to see how we can fit it into hospital ED, GPs, ambulances, and it's got to be able to be clinically acceptable and analytically compete with existing core technologies. But we think we can do something there. That's a goal that we've got going forward, because we like making stuff here. So I think that's pretty much where we're at the moment. We're about 1,400 patients, as I said, recruited into the 3,000. We want to keep going. We're very keen to do a larger sero survey in the population now that Omicron has ripped through, ideally up to about 10,000 people. If you get the statisticians involved, they'll tell you should sample from everyone, but that's not technically feasible, so they have to give us a number, and 10,000 seems to be that number. That's one of the things. So I just want to thank some of the team here. So this is the senior leadership group of the CHI here. These are our animal workers led by Chris Charles and Miriam Radmaker here. This is the assay lab that I head. These are other workers in the clinical, Lorraine Skelton here, and these are the Fantastic Four from our COVID team. Sarah Roudset and Jackie Lee are the major technicians. Judy here, who is a fantastic phlebotomist and general easer of people who don't like having needles stuck in them, and Lorraine Skelton, who manages everything on a day-to-day basis of our Cantata project. And so finally, I'd just like to thank everyone for listening, and also our funders, particularly MB, who have been extremely easy to deal with and very, very helpful in terms of the project, and also the subsequent funding that underlies all the cardiac stuff that we're doing from the HRC and the Heart Foundation of New Zealand. So thanks very much for listening.
So thank you, Chris. That was really. I must admit, I'm not a biochemist. It was fascinating, and I think I got the gist of your talk. But here's a question for you that's kind of like maybe a little bit superficial. But how do you get involved in your study if you're outside of Christchurch? I mean, there are Kiwis here that is all over New Zealand.
Yeah, well, that's an interesting thing. So what we did was we did something we don't. In fact, I don't know that we've done it before. We've entered into an arrangement with Asia Pacific Health Group through Southern Community Labs here. So if you're in a different location, we've had people from Kaitaia, we've even had someone from Lumsden in Southland. That was amazing. But if they can email me or email someone in the group, just Google us and you'll find us there, either me or Lorraine Skelton, and send us an email and say that you're interested, and we can send you the patient consent forms and all the information sheet. And if you think it's something you want to be involved in, we will send you the tubes, and you can take it to your local bleeding station. We'd let them know, and they'll just send everything to us at no cost to you. We will cover all the costs for the phlebotomy and for the couriering to us. So we can go nationwide because of that system.
Okay, and there's any specific criteria for the recruitment?
You have to be over 18. Other than that, no, we'll take anybody.
Have had COVID? Not necessarily.
Yeah, COVID, non-COVID, people who. One of
Omicron.
The tricks, yeah. One of the tricks we had to pull with the ethics committee was somebody got a bee in a bonnet about it, and so we changed the recruitment to people who had a proven diagnosis of COVID, plus people who've been associated with those people with a proven diagnosis of COVID. And we just went down the line and, associated with this one, then this one, then this one, then this one. And eventually we got it in because they realized that we were going to do everybody. So it doesn't matter who you are.
Thank you. So just that was just a little bit of a plug for your study for the New Zealanders here.
Chris, yeah, I'm interested in your device idea. First, I was also interested in your grant story. I just had to think about COVID. COVID just showed, and I think Deepak would appreciate this as well, our health system can be really agile and quick when we decide to. When you don't decide, things just seem to go on forever. But just I think there's so many examples where things just happen so quickly. just
Oh yeah.
decision that,
don't
yep,
just-
we got to get it done.
Yeah, and it was just fantastic. You know, we appreciate that there has to be processes and everything, but it was amazing. And once you've had that experience, you want it again.
You've had a taste. I just see your device, so that's just, you're just looking for like a really qualitative device, but has that scope and sophistication. Is that right?
Yeah. What we're looking for is a wide range of things too. So we don't want to just most in our experience, and you guys are the medtech experts, you'll know more. But in our experience, most of the POC devices are only issuing one, maybe two results, or if it can do multiple tests, but you only do them one at a time. We want something that can churn out 5 results at once. Now I realize that's a bit of a technological challenge, but you know, we like that, and that's ultimately where we'd like to get to.
Where are you at with that? Like,
so we've got basic concept designs sort of in our head, but those need to be brought back to reality by the mech eng and other experts to say, well, no, you can't do this, you can't do that. So you know, we need to have proper discussions, serious discussions with the appropriate people about.
Look, I know you have great engineering there in New Zealand, but I also know there's at least one biomed engineer on this call. We have so Goff, who's got his photo there. Goff is our biomed engineer in residence. She sits in hospital and works a whole bunch of different things. So yeah, if there's some areas we can help out with that, if you identify challenging areas, we can come and find the skill sets over here, might be able to help.
That'd be great. Yeah.
Anyone else have any other questions? No? All right, thanks, Chris. We might think of some before we get to the end. So I think, yeah, thank you for that. And we'll move on to our third speaker now, Associate Professor Deepak Bhonagiri. And the first thing I want to do is thank Deepak for joining in today. People don't know, Deepak travelled to India on Tuesday and this started at 6:30 in the morning for him, and he was still happy to join in. So yeah, thanks very much, Deepak. So Deepak is an intensive care specialist at Liverpool and Campbelltown Hospital, Stream Director of Critical Care in the South West Sydney Local Health District. And for our New Zealand colleagues, our LHDs are akin to is or was your DHB. I know they're kind of changing soon. Deepak's also the co-chair of the Virtual Care Working Group in the South West Sydney LHD. He's Clinical Associate Professor at Western Sydney and Macquarie Universities. He has a keen interest in virtual care and telehealth. And he actually received a grant to evaluate a virtual enhanced model of care for level 4 ICUs in New South Wales. In addition to routine ICU monitoring, he's also conducting a phase 1 trial of wireless remote monitoring using wearables and then using AI to detect clinical deterioration in hospital patients. And his other research interests are sepsis and renal replacement therapies in ICU, as well as the medical emergency team rapid response systems. So yeah, Deepak, thanks very much for joining in again today, and I'll hand over to you.
Thanks, Lance. Can you see my screen?
I can, yep.
Yeah, right. So yes, so thank you. And look, it's absolutely no problem. It's like I said, it's a nice warm day here, but it's very nice early in the morning. And thanks for asking me to speak. So I'll be talking mainly about value-based care, but talk more about it with kind of virtual care or telehealth as the focus. I mean, it's very different from the 2 previous talks. This is kind of pivoting out of, you know, the extremely high level talks that David and Chris gave about, you know, diagnostics and management of individual COVID patients using immunology and testing to kind of care delivery, or the model of care that can be delivered to look after patients within rural and regional places where COVID can still occur, and how we help those ICUs within New South Wales. So telehealth or virtual care, look, the terminology keeps changing, and it pretty much is the same, although in New South Wales currently the expectation or the, we call it virtual care. It's been around for years. Models of care have been used in the US for many years, and they showed improved mortality. We set up a virtual care working party for Southwestern Sydney and eHealth, and we traveled all across the US looking at their models of care, wanting to implement similar things within our LHD, not necessarily in ICU, but also in ICU and other places. When COVID hit, we had to rapidly accelerate this model of care only because some of our smaller ICUs had no specialist intensive care staff who could do rounds every day or look after these patients. And we were expecting, and we really saw a huge number of patients turn up to hospitals, and we wanted to be able to look after these patients within our smaller ICUs. The Southwestern Sydney Virtual Care Executive Working Group was set up, and we used that as our governance structure to help with this. Sorry, just can't get to my, I'll get to my next slide. Yeah, so to kind of give you a bit of background, intensive care services within New South Wales have divided into level 4, 5, and 6. The tertiary ICUs, which are the big teaching hospital ICUs where everything is done. The level 5 or metropolitan ICUs, which is our Campbelltown and Bankstown ICUs, which are really places where you can do everything but cardiothoracic surgery, neurosurgery. And often with the level 5 ICUs, there's not access to other services like interventional radiology and some other services. And our small ICUs, which is our Bowral and Goulburn, which is where there are no intensivists on site often, where the patients are looked after with what we call single organ dysfunction, and anyone who's complex requiring ventilation, renal replacement therapy, and so on is moved out to another hospital. So within level 4 ICUs, the models of care are either they're close collaborative. So some of the level 4 ICUs have a full intensive care team that is led by a specialist, and they provide the leadership and the care that's required. The open model is where there are no specialist intensive care medical staff. There's nursing and there's physicians who are associated with patients and surgeons who look after the patients. So what we wanted to do is to provide an enhanced model of care to regional and rural ICUs to support the local staff and involve all aspects of hospital medicine, including medical staff council, the hospital executive, and our local health district executive. Use existing technology, because we realized at that stage trying to kind of implement new technology was not going to be possible. Provide training for nursing staff at regional sites by secondment to larger ICUs. So we got some of the nurses from the smaller ICUs into our bigger ICUs to train them up and provide them that education and the confidence to look after patients. And also we initiated a system of rapid and proactive transfer of patients requiring a higher level of care. So if we thought somebody need to be moved from a smaller ICU to a bigger ICU, rather than have that 6 and 7 phone call system, we just say, yep, they can come in straight. We organized a call retrieval service and move them rapidly into our bigger ICUs. So what we saw, we did some initial work with 3 to 4 months of implementation of this, and saw a reduction in the serious adverse events that were reported. The staff was satisfied in the rural ICUs, regular multidisciplinary rounds. What it did was we had rational antibiotic management, rational medication management. We had goals of care discussions. So what that meant was patients sometimes in these level 4 ICUs were reaching the end of their life, and we were able to give the local staff the confidence to put them on a palliative care pathway, and the medical staff were engaged and they felt empowered to look after their patients, and they felt confident to look after them there. We had regular governance and QA meetings to close the loop so that those ICUs essentially had the same structures that our larger ICUs had. So we then embarked on a 24/7 EICU project to do a comprehensive evaluation of remote ICU supervision of the level 4 ICUs. We had patient, clinician, and hospital executive involvement. a multidisciplinary team of experts conducting the process, multiple agencies. So our e-health, which is the governing body for all e-health initiatives in New South Wales, were involved. We had a group from the Australian Institute of Health Informatics at Macquarie University that was involved. We coordinated, Campbelltown Hospital was a control center, and we had level 4 sites initially at Bowral and Goulburn, which are our rural ICUs. And we used existing hardware and software, and there was no change in the model of care of staffing. We knew we had to do this rapidly, so we couldn't change the staff, recruit more staff, have funding for more staff. And this was our research team. So Anurag here is a health economist to help us. That's me. Reba here is from the Australian Institute of Health Informatics, and she was the one who looked at the evaluation model. And then there's Ken Hillman, and Ken is the professor of intensive care, and he's done previous health services research. Heidi is a research coordinator at eHealth, and she helped us with the eHealth side of things, because we looked at some hardware, evaluation of some hardware. Michael Parr is the director of ICU at Liverpool, and he had some experience with the US-based team that were running a remote monitoring of ICUs for the US from Macquarie University. And Jack is a clinical epidemiologist who's got a lot of experience in clinical epidemiology and systems research. And we put in a grant application, and we were able to get a COVID-19 research grant that was funded up to $500,000 Australian dollars. And we said that we'll address the safety, quality, and economic evaluation of a 24/7 virtual care enhanced intensive care model of care to support local management of critically ill patients requiring transfer to a higher level of intensive care. It had never been done before. We'd look at patient experience, patient outcomes, and telehealth usability and user satisfaction. So we plan to do a whole comprehensive set of evaluation, including looking at mortality from a benchmark ANZIC's adult patient database. So for those of you, and many of you would be not familiar with this, but every ICU within Australia and New Zealand, I think 97% of ICUs subscribe to the ANZIC's, which is the Australian New Zealand Intensive Care Society Adult Patient Database. And the database provides these kind of funnel plots to benchmark mortality. So if you sit within this funnel, it means that your mortality is within the 95% confidence limits of your peers. Obviously, if you sit outside of this, it means that your mortality is higher than your peers. And what we do if that happens, and we see that in 2 successive quarters of an year, we do some outlier analysis. And generally what we found is that there's something in the model of care, something in the data capture, and we act upon it. We've acted upon it in many ICUs, and what we found is that changing the staffing of the model of care brings people back into the funnel with their peers. So we used a learning cycle or a learning health system, change management system, methodology to support the ICUs. We looked at performance to data, data to knowledge, and knowledge to performance, and a continuous cycle of change to do that. And this is a patient-centered rapid health system, change management system that we used. What we did was to use, like I said before, to use the continuous cycles of change to capture practice as data, assemble the data, analyze it, interpret the results, and keep working to continuous change cycles. What we did not want was to just get a paper out of this. What we also did not want was gaps in our data. So the initial gaps that we identified were the regular review of patients in ICU by senior medical staff, early recognition of deterioration, overnight admission process, and peer support for nurses. And we fixed that to close that loop using a 24/7 remote monitoring by qualified ICU nurses who would then talk to the nurses on the floor and suggest changes. If there was medical intervention required, we had the local team, the registrars in the ICU at Campbelltown who would help in, or if they needed escalation to a specialist like me, that was done too seamlessly. So value-based care, which is what we used in New South Wales, it is care that improves health outcomes that matter to patients, the experiences of receiving care, the experiences of providing care, and the effectiveness and efficiency of care. And we use this metric to do our evaluation. This is the leading better value care. They look mainly at diabetes, osteoarthritis, and so on. So this was the first time this value-based care was implemented in inpatient critical care services. In the US, value-based care means different things to what it means in Australia, and in the NHS in the UK, it means something different. In the critically ill, what we think value-based care means is survival, mortality, care closer to home, high standards, specialist-driven care, seamless transfer, compassionate, empathetic care, recognition of deterioration, and timely decision-making. And that's what we delivered using our 24/7 EICU care. The mixed method experimental evaluation that we used was quite comprehensive, as you can see from this slide. And we are collecting a lot of data. And all the data that we are collecting, a bit of it is existing, and the rest of it is data that we have tailored for this project. And the outcomes that we are looking at are care closer to home, the number and reason for transfer to higher facilities, higher standard specialist-driven care, frequency of ICU specialist review, seamless transfer to higher level of care, as I spoke before, and the recognition of deterioration. So we've looked at the recognition of deterioration, and we've set up a whole program around that in the smaller ICUs. And that is something that we will report upon. We also look at the experience of receiving care. So that's a patient-centered, patient-related experience measures. And we've got data from about 100 patients now from our sites. And we are in the process of analyzing that. And we've also looked at experience of providing care. So we've done survey-based experience, and we've also done face-to-face interviews with many of our clinicians who provide care. So, so that's been done independently by a researcher at the Australian Institute of Health Informatics. So the effectiveness and efficiency of care, we're going to measure it using mortality, severity of illness, length of stay, intervention performed, and efficiency will be measured using the number and efficiency of transfers, clinician confidence, and health economic evaluation. Safety and quality, we are looking at the number and serious adverse events and their classification, health economic, and device integration, use of electronic medical records to enhance supervision. So we're also looking at sustainability and scalability. So the sustainability model is now kind of proven because we've done this for almost 2 years with not too much of enhancement, and within the budget that we were allocated. We've looked at scalability, and we've added an additional site at the moment, and we are looking at scaling to other sites within New South Wales. And progress will be looking at a national model of care and setting up national control centers so we can look after up to 20 to 25 rural ICUs from these centers. We also added in, and I've just about received the ethical approval to look at remote monitoring, remote wireless device trials to measure the saturation, blood pressure, respiratory rate. We are looking at the Bioformis Everion devices, but there are other devices that are available, and we're looking at at a wireless blood pressure monitor as well, to collect the same data that we collect in ICU for all our patients and have it available for clinicians. The software has an AI element that will allow us to recognize deterioration, and we are going to compare the AI software to a clinician, like a senior nurse who recognizes deterioration using the current data that we achieve, and we're going to get those clinicians to tell us whether they think the AI is as good as their own observations doing 24/7 evaluation. We're also going to talk to our patients and see what they think about having these devices attached to them 24/7. So we're doing a comprehensive evaluation of that. Initially, we're doing a phase 1 trial with only 50 patients in it, and we'll later, if we get funding, increase it to look at a larger cohort of patients. The other remote monitoring trials during COVID. Sorry, have I run out of time? Or no? Okay. The other things that we looked at are glasses to assess the utility of these. So the glasses are something you wear, and we can remotely see everything the wearer of the glasses can see, and this gives us a better idea of our patients, and we look at our patients. It was challenging because of its integration into our EMR, and we needed 2 or 3 screens, but we did a short trial of it, and we're working now on integrating it into our EMR so we can use that to triage of patients, to transfer them out of these remote and rural sites into our larger sites. The other one that we got funded was to look at some imaging technology. So this is kind of devices we'll use to look into patients' ears or to look at our patients. And we got funded for this software and the hardware, and we are now going to implement it in our emergency departments to reduce the number of transfers from rural emergency departments into larger centers, to help with patient care. So what we're going to do is we're going to look at patients and see if they can be safely referred for outpatient care as opposed to urgent transfers to tertiary level emergency departments using these devices. So we again using a value-based care to look at effectiveness, efficiency, patient experience, and clinical experience, as well as health economic data for these device trials in ED. We've also set up a virtual center and a virtual concierge to help us with all these trials that we are running. The control center will help us monitor any of the patients within our rural ICUs, as well as any patients within our hospital. And it's set up as a discrete center where we will have 1 or 2 nurses with medical support who will support all these clinical trials that we are running using our value-based care, and which are being funded at the moment. We've got another funding application of translational research. So we're hoping to get more and more funding and to do some funded device trials too, with some commercial partners using this value-based care approach that we've got. The other bit of research, clinical trial research that we recently signed up to is to look at machine learning to enhance clinical care of patients with traumatic brain injury, led by a group in Western Australia and Melbourne. And this is going to be really cutting edge work in the management of critically ill patients. And this is something that we are very excited to be part of. The Macquarie University Emory ICU Center, that's something I spoke about before. This is looking at what is already implemented in radiology to look at remote monitoring and management of patients using the 24-hour clock. And we did that for a center in Emory in the US from Macquarie University, and that site was successful. It's been worked up as a commercial model of care and for implementation, and we're going to jump through all the hoops of regulation that are used in the US. The My Emergency Doctor, we're using a similar model of care, and we're going to try and utilize accredited fellows of the College of emergency medicine to support junior staff in some of our EDs, and we're going to do some value-based evaluation of this implementation. In India, where I'm sitting at the moment, they did a short trial in 28 districts, rural districts, had 10,000 patients, and they looked at, they did some early kind of very short and dirty evaluation, and they found that this model of care works well within India, and we're putting in a broad submission to scale and sustain this model of care using an Australia-India collaborative research grant that's available. And this is the US tele-intensive care that was implemented. And as you can see, huge number of centers during COVID-19 used telehealth models of care to support patients in rural and regional centers and avoid transfers and manage patients locally. So this is the kind of research that we are doing. It involves a lot of culture change and leadership. It involves working with clinicians, health executives, ministry, and so on. And we at the Ingham have a leadership role in this. So I might stop here. I know I've gone a little bit over my time. Happy to take any questions from people.
Well, thanks so much, Deepak. Given how much info you covered there, I think you did fine with the time. I'm not sure where you're going to get to sleep covering all of those things. Any questions from, well, people thinking, so I know you're about to launch your command center in July down in Campbelltown. What, if I was to walk into there then compared to, say, a year ago, what would look different? Like, what does the supervision look like? I'm sure it's not just someone grabbing a phone and calling you when they have an issue. So
yeah. So in July, initially, what we're going to do is we will be implementing some of our remote monitoring as a trial on patients who are on the hospital wards, selected patients, and they'll have these wearable devices 24/7 plugged into at the moment, what's the commercial software solution with AI. And we're going to use that to recognize deterioration in those patients. So that will create an early warning system, and our nurses, we'll have 24/7 nurses in our control system who will be looking after probably about 20 patients. And the first tier of response is that nurse will pick up the phone and speak to a nurse in the ward and say, look, I've noticed a deterioration in this patient who's in a single room. Can you go do a set of obs and call me if you need me? And one of our doctors and nurses, if they need it, will turn up immediately, evaluate the patient, and rapidly move them into an ICU. So what it'll do is it'll give a proactive 24/7 monitoring. At the moment, what happens to nurses, to patients on the ward, is observations are only done every hour. So if you deteriorate between those hourly obs, it's not being picked up.
Yep.
So what we are doing is monitoring them continuously, picking up deterioration rapidly. So to give you a scary scenario, and this is true story, we had 2 deaths in the last 6 months at one of our hospitals where patients had the obs every hourly, but between the 2 obs, the nurse turned up and the patient was in cardiac arrest. They were essentially dead. Nothing wrong with the nurses, nothing wrong with what we're doing, but because of the monitoring not being there, we couldn't pick up the deterioration. So what you're doing is you're doing CPR on a dead patient as opposed to picking up the deterioration and turning up and fixing a problem. So that's what we want to fix. I know it's a scary proposition that patients can die, but it still happens. It doesn't happen very frequently. But even if we can save 5 lives a year, we'll have justified the entire system we put in. And it isn't patient selection. We're not going to do this for every patient, but we have a model and we want to work out a model using all the data we have of what patients we are going to put on these monitors.
I guess the attractive thing is the technology itself is not new, inventive, but it's being used in areas just not not applied to the area that you're applying it to.
And the whole system, it's not very expensive. The biggest expense I have is with the nurses 24/7. And that's something that we're writing. And if we can prove that these things work, there will be funding and there will be funded nurses who do just this. And we can write algorithms to monitor up to 100 patients using 3 nurses.
Yeah, no, great.
So would you, at some point, I mean, this is a fantastic model for, in the first instance, as you said, ICU and then hospital care. Would you take the same model and take it into the community? Because, you know, one of the things that's kind of missing in the community is that you have got wearables available and people monitor themselves, or, you know, Apple's monitoring you. Yeah. But there really isn't kind of like a centralized system that you would trust, you know, especially for perhaps chronic patients with chronic disease, which is really deteriorating.
Yeah, so during COVID, and I don't know whether Josephine Chow has presented some of her work in this forum. So we sent patients home with the pulse oximetry and so on, and we developed a system where they could self-report their saturations and so on. The next step is to use this wireless thing to connect it to a phone and receive an upload of the data from the patient's phone into a centralized control center. So there's some work done through the Royal Prince Alfred Hospital in Sydney, where they've set up that EMR integration that's needed. At the moment, it's still in its infancy, but I don't think it's going to be very long when patients who come to ED will, some of them, or patients who discharge home from hospital, or patients who come to see a GP and who are sick, will be sent home with a monitor. The monitor will be beam the data into the cloud, and through cloud computing, we'll have a control center that can sit anywhere in the world that will look through AI algorithms and alert either an emergency doctor, their GP, a nurse, or some such person of their deterioration. In the first instance, based on their there'll be a tiered response based on their deterioration. Either we rapidly send an ambulance to pick them up and get them into hospital, or we call them and say, are you okay? And we send another team, or we tell them, go see your GP tomorrow, or we tell them drive to an ED. So that's where we're going to take this. That's where we want this to go eventually. But we are in the first steps, and we have to go through the whole kind of culture change, the governance, the, there's a whole body of work that needs to be done around this. And we've just started doing this. So this is the first step in changing the way health is delivered to patients, and to make it so much more patient-centered that patients get the care they need within their homes, as opposed to having to come to hospital, and we'll monitor them and we will send all the care that they need to them.
That's good. Can I ask one more question, please? So this is about the sustainability part. So you kind of indicated that, you know, you've had quite a few rounds of funding, and, you know, there's the sustainability from that part. But in the long run, you know, do you think the government will actually purchase the system, you know, the whole model and use it? Because, you know, we've had incidences where things have been proven, you know, in trials to show that it's been really, really good, but still there is that resistance.
Yeah, so at the government level, at the ministry level of New South Wales, they're putting in an enormous amount of funding to support precisely the work we're doing. As a clinician and somebody who works in research, it's my job to do the research and present it effectively to government and get the funding. Look, I'm quite confident in my discussion with the ministry that the funding in terms of sustainability will be available, at least in New South Wales. The main barriers that I see that I need to overcome are my own colleagues, the clinicians, because it's going to change the way they work, my nursing colleagues, my medical colleagues, and it's also demonstrating to patients that this is safe, this is
Yeah.
good, and
Mhm.
this is for your benefit. So that element is almost as important as the money. Because
Yes.
technologically, this is not very, we're not doing something groundbreaking. This already exists. But we've just got to prove to people that, we can do this, and we've got to get our patients to feel empowered and for them to say, this is safe, and I like the way this is being delivered. And our clinicians to say, look, this is good. This is helping my patients. It's helping me do my work more efficiently.
No, thank you for that. And your work's fascinating.
Because another, like I said to Chris earlier, I think it's another example where I know you were working on this before COVID, where COVID accelerated, I think maybe the validation of the model and what you've been doing. So we have COVID to thank, hate it for a lot of things, but thank it for a few things as well. I'd certainly invite Chris and David and anyone else to ask questions or Chris and David to take any questions now as well. The format was to finish up with a panel, really just open questions for any of our speakers. So yeah, it's just open to anybody.
Can I ask a question?
Of course,
Yeah.
Helen.
Yeah.
Hi, my question is for Deepak, and sorry that my camera's not on. It's decided to not cooperate with me today, despite everything. Thank you so much for your presentation. It was really, really amazing to hear about the value-based healthcare research going on in Australia. My question is about patient-reported outcome measures and whether you are utilizing them in your research. And if you are, what's the engagement like? How are you distributing it? How are you collecting the information? And how does that factor into the value-based healthcare calculations that you do?
Yeah, so thanks, Helen. And that's a great question, because I think, look, for we certainly are collecting patient-related experience measures, and we've got a standardized tool. So what happened, Rima, who works with me, before she joined our team, and just around the same time, she got grant funding to precisely set up a validated patient-related experience measure for telehealth or telehealth measures, and we are using that validated tool. That is now kind of something that's got a fair bit of research behind it. It is being set up by, it's got a lot of background to it now. So we certainly are using patient-related experience measures. How we are doing it is I've got independent research coordinators at each of our rural sites who we are paying, and we train them, and they collect the data manually for me, and then I collect the manual data on a piece of paper, and then we kind of put it into the database, and then we are evaluating it, and we'll be producing a report fairly soon using these validated patient-related experience measures. And I think although we are collecting it, to me, when I look at telehealth, and sorry to kind of digress, we are looking now at virtual care or telehealth in two ways. We are looking at patient-centered telehealth or patient-involved or client-involved telehealth, and we are looking at peer-to-peer telehealth, which is clinician-to-clinician telehealth measures. And certainly our virtual care ICU is more of a peer-to-peer or clinician-to-clinician telehealth measure. And in my opinion, patient experience is really important, but the most important thing is the clinician experience measures that we are collecting, because this is an example of a clinician-to-clinician network, and that those measures I think are very, very important in this. And we've got some validated clinician experience measures again that Rima's written, and we are collecting extensively using those. So I hope that answers your question and helps.
Yeah, it does. That's really interesting to hear. Thank you so much.
I got a question for David, but it's based on Chris's data. Like between the two of you, the number of markers and things you looked at is just phenomenal. I was just wondering, David, if that IgA response that Chris's work picked up was something you saw or or was that a surprise to you as well? I can't. You looked at so many things. I can't remember. IgA was in there.
Yeah, we did measure IgA, and I think the response was similar to what Chris reported, in that, as you would expect with IgA, it kind of peaks pretty quickly and then wanes after that. But I don't think we found any correlations between IgA and any kind of adverse outcomes related to long COVID or anything like that. So yeah, I was also interested in the cardiovascular biomarkers that Chris was measuring. Obviously, we didn't measure any of those in our long COVID study, but given the data on cardiovascular outcomes, it certainly would be interesting to assess some of those things. We probably do have some serum left, Chris, if it's of any interest to you.
Absolutely.
We do.
If you want to know the answer, we can easily measure those.
Yeah, we do have a vaccine cohort as well that we've been following with a kind of similar systems level type analysis. We haven't published that yet. It's about 85 Pfizer participants and a smaller number of participants who got the AstraZeneca vaccine, which started to roll out here and then was largely stopped. We've quite a lot of different blood samples and things collected from that. If there's any interest in measuring something on some of those, I'd be happy to talk to you offline about that as well.
Yeah, absolutely. That would be great. The one thing I did forget to mention also is that we're about to start looking at primary and secondary immunocompromised folk. So primary disease is obvious, but of interest to the immunologist here is if they're getting treated with something like Ritux for knocking out the B cells.
Yeah.
What happens there? So that's another area that we're interested in looking at.
We have a small number of those collected. It might be productive. I'm not sure. I think we only have 20 patients or something with CML. It might be productive to just contribute them into a larger study if you're.
Yeah, I think that's exactly right. Two is better than one, right?
Yeah.
Any other questions? We're almost coming to an end. No, nothing else from you, Diane?
No, no, but I just like to say that perhaps in that last conversation, there might be a really nice little collaboration between David and Chris, which is kind of like the purpose of the BioBridge. And Deepak, I think there's quite a few people that will reach out to you, and I'll certainly do that because I've got other colleagues that would be interested in the work that you're doing with the virtual ICU.
If David and Chris, so David and Deepak, or David and Zeneman through Deepak.
Yeah. I'll get you in touch with Anders and with some of the other people who are doing the long COVID clinical research, because clearly, if they've got some samples and in our labs and we can access those, that'd be really good. Because I know as part in the Omicron wave around January, we were doing a lot of the spike protein assays on all our patients who came through in New South Wales, because our chief health officer sent us a specific thing saying, please send blood for spike protein assays, because they wanted to know if, the level of immunity and so on. So some of that, some of those tests are probably available in New South Wales, and I can get you in touch with people who are looking at that out here in New South Wales.
That would be really helpful.
Right, well,
if I could just plug something for people who are still hungry for yet more COVID things. I'm on the organizing committee of a COVID conference that will be held in Sydney in July. Sorry, I should know the dates off the top of my head, but I don't. July 21st and 22nd, the second Australasian COVID conference 2022. If anyone wants to Google that, I should have thought to put a plug in the.
Look, if you send Di and myself some info on that, we'll put it up on between us and the BioBridge and across our network, we can put some stuff up on that for sure.
Excellent. I'll send something on to you.
Yeah, that'll be good. So yeah, so we'll wind up there. So just on behalf of Diane, myself, and the BioBridge, thank you, David, Chris, and Deepak for your presentations today. Lost a few people along the way, but I saw that nearly everybody stayed right to the end of Deepak. So thank you very much. Di and I are happy because we've identified some good connections and collaborations to make to help you with your work, which is one of our personal goals of the BioBridge. But thank you very much for people who are still on. The event was recorded, and that'll be put up on both the CMDT and the LIP website for people to go and have a look at as well. Unless there's anything else, we'll wind up there. Diane, anything from you?
And just reach out if you need any help. And part of the purpose of the BioBridge for everyone is actually an exchange of delegations from Australia to New Zealand and New Zealand to Australia. So just let us know if there's something that the three of you actually want to work with together. Okay, cool. And thank you, Robert. You're from Atlanta.
Thank you all. Thanks to the other presenters too. Mind-blowing work. It was really a privilege to see it.
Yeah, it's just amazing. It actually makes COVID really interesting to me now. It's kind of starting to get tired of it. But no, thank you, and enjoy everybody. Thanks very much again, David, Chris, and Deepak.
Thank you.
Thank you.
Okay, bye.
Bye.